In Lesson 11 today, we're talking about reciprocals and multiplicative inverses, order of operations, and products of signed numbers. Now, we're going to start off with a few definitions, and the first one is that of reciprocal. Okay, hopefully you remember what the reciprocal of a number is. If we have, let's say we have the number, let's say 9. For 9, the reciprocal is going to equal 1/9. And one way we can look at these numbers, 9 is really the same thing as 9 over 1, so 9 over 1. We're just switching the numerator and denominator to find the reciprocal. So the reciprocal of, let's say, 17. The reciprocal of 17, the reciprocal of 17 would be 1 over 17. How about negative 1 over 35? The reciprocal of negative 1 over 35, well, it's not equal to. Let's reverse that. Undo that. It's a nice feature that we have here. Negative 1/35, the reciprocal of that is going to be negative 35 over 1. Notice we kept the negative sign. Okay, we kept the negative sign because we're only switching the numerator and denominator to find the reciprocal. Now, multiplicative inverse, that's a fancy word. Try to say that, multiplicative inverse. Okay, multiplicative inverse is the exact same thing as the reciprocal. So if I asked you to find the multiplicative inverse of negative 7,231 over 17, well, you would have a quick answer for me. You'd say, Mr. Wilkinson, the multiplicative inverse of negative 7,231 over 17 is going to be negative 17 over 7,231, and you'd be correct. Now let's look at a problem that we need to simplify. Okay? In this problem, we're looking at 4 times 3 plus 2 plus negative 3 times 5. And in this problem, we do have to pay attention carefully to the order of operations that we use. Let's go through this problem right now and solve. We're first going to do 4 times 3. That's 12. We have 12 plus 2 plus, and then we have negative 3 times 5. If you remember order of operations, and we'll talk about that in a moment, you know that multiplication goes before addition every single time. So we've got negative 3 times 5, that's saying the opposite of a positive. The opposite of a positive is negative, so that must be negative 15. And then we can go ahead and add. 12 plus 2, that's going to give us 14. And we've got 14 plus negative 15, 14 plus negative 15. That must give us an answer of negative 1. Negative 1, we're all done. We've simplified that problem quite handily. And we'll move on to our next thing. Our next thing is actually order of operations. And order of operations, this is critical. This is critical that you know this one, the order of operation. Please excuse my dear Aunt Sally. Okay, PEMDAS. Hopefully you remember this. Please excuse my dear Aunt Sally. We work in this order. We always do this first, and then we do this last. Okay? We're going to work from the top to the bottom whenever we see a problem like this. PEMDAS. What does that mean? Other than please excuse my dear Aunt Sally. And I'd like to hear the other acronyms that you can come up with for this. Okay? This is the acronym. Come up with different sayings. PEMDAS. But the mathematical one is always going to be parentheses first, exponents second, multiplication and division third, multiply and divide, okay, and then next is going to be add and subtract. Now, addition and subtraction, multiplication and division, those are special because if you have both multiplication and division, you work from left to right. L to R, left to right. And if you have both addition and subtraction, you work from left to right. So let's look at one example. Let's say we have this. We've got 7 times 9. Okay, and we're going to divide that by 3. Then we're going to add 2 and subtract 1. Okay, well, we've got multiplication and division. It says multiply and divide. It says add and subtract. So Multiply and divide are equal. We're going to go ahead and we're going to multiply first because multiplying is on the left. So we get 63 divided by 3 plus 2 minus 1 plus 2 minus 1. 63 divided by 3, that must be 21. 21 plus 2 minus 1. We've got addition and subtraction. We're working left to right. 21 plus 2, that's 23. 23 minus 1, keep that in your head. 23 minus 1, that must give us 22. And that's one example that you can see where we have both addition and subtraction and multiplication and division in the same problem. It's very important that we use the correct order of operations so we get the right answer in the end. Our lesson practice is going to be on page 53. Make sure your notes are completed. Have a good afternoon, and I'll see you next time in class.